So now we will tell about the ECG, electrocardiography. Okay, electrocardiogram. So electro mean electricity, electric conduction. By the using of electricity, by the using of the electricity, we use heart. Okay, heart visualization to see the heart. That what is present in the heart, what is going on in the heart. Okay, so first of all, the thing is this is your heart. Okay, this is your heart. I have draw your heart. Okay, and now you have to remember that standard ECG have 10 electrode. Electrode is actually a metallic strip. Okay, so these are 10 electrode. Four are limb electrode, and six are chest lead. Okay, and that six are called pericardial electrode. Six are the chest lead are also called pericardial electrode, and the full limb that is present. Now we will tell about different thing about. So how, for example, this is a person. Okay, now there are 10 electrode. So the four of them. Now first of all, four of them are actually limb lead. So one is here, another is here, another is here. These are four limb lead. Okay, now second thing is about the chest lead. There are six chest lead. Mean one, two, three, four, five, six. Six chest lead. I just remove. So how, just we draw again. There are six chest lead. There are six chest lead. One, two, three, four, five, six. These are chest lead. They are present on the thoracic, on the sternal side, on the chest. Okay, so now total are 10. Okay, so these are actually electrode. Now about it create, for example, these are 10 electrode, and it create 12 lead. 12 lead. Okay, it create 12 lead. So what is lead? Now about the lead, you have to understand lead is actually that measured the potential difference between 2 points, that is called lead. Okay, so how it created? Now if you go to the limb lead have actually, there are four lead, four, there are actually six limb lead. How? Actually it have six limb lead. Now we will tell about the, first of all, it is actually the chest lead is from V1 to V3 6, and it create only six lead, six chest electrode and six lead. So in transverse plane, if for example this is your body and you cut the body and you see from the transverse section, so chest lead is actually see your heart from the transverse section. So this is your heart, this is the thoracic cage, etc. So you put all the lead, 1, 2, 3, 4, 5, 6. Okay, six lead on this, like this, like on the chest, like this. You place all the lead like this. So these are six lead, six electrode and six lead. Okay, so they see the electrical activity of the heart through the transverse plane. This is actually the chest lead. Now go to the coronal plane. For example, this is your body. We have already discussed the coronal plane and transverse plane. Okay, for example, this is your body, and this person have face is to like this. Okay, this is their air. Okay, and now they are actually like this. Now just see, they are moving in this direction, they are moving in this direction. But if you cut him like this, if you cut him from this side, okay, this is called coronal plane. Okay, so from the coronal plane there are 12 lead created, that is called non-metallic electrode are present, non-metallic. Okay, so first of all, that is actually augmented, that is the unipolar lead. Augmented unipolar lead, augmented mean that amplify There are now, these are called six, these are actually four limb lead, and these four limb create actually six lead. Six lead. Okay, how? Now let's see it. Okay, so actually these four limb lead are present. One is on the one hand, another is on the, but here is one is the neutral lead, one is the neutral lead, so it have no role. Okay, and these three are actually so they create a triangle like structure. Okay, that is called an two-end triangle. Now we will explain everything. Okay, so on the right arm and on the left arm, these are two electrode are present, and on the left leg the electrode is present, and on the right leg there is a neutral lead present. Okay, so these are positive sign here, positive sign here, and positive sign here. Okay, so if you see between them, between them, this is called, these are the two potential that here, that know the potential between these 2 point is called lead. Okay, so now there are three lead are like this. Okay, these are three lead. Okay, this is lead 1, lead 2, and lead 3. What? This is lead 1. Okay, and this is lead 2, and this is lead 3. So now these are three lead. Okay, another is, these are three lead. Another is augmented lead. Augmented lead are actually unipolar. They are created by a scientist. You don't worry about this. Don't, like, just see that one lead, one lead see the heart from the inferior side, and one see heart from the left side, and other see heart from the right side. So it is actually augmented lead. Here is a resistance is used, and they actually, for example, if you see, if you put the lead like this. Okay, so it see the heart from the inferior side, and it see heart from this side, from the right side, and it see heart from the left side. Okay, so now just see. Okay, here are AVF lead, and here are AVF lead, AVL. Now this lead is called AVF, this is called AVL, and this is called AVR. Augmented, this is actually augmented lead that amplify the current, that amplify the electrical signal that is showing from the heart. Okay, if anything happening here, this will be showing here in this lead. Okay, so these all are the lead which I have tell you. Now 12 lead are here. Okay, so AVF, AVL. Now we will tell about their angle also. Now 6 lead from the limb electrode and 6 lead from the chest lead. So total lead is 12 lead. Okay, now actually this is a unipolar lead, we have already explained. Let's come that how these lead measure the electrical activity of the heart. So first of all, this is the myocyte. Okay, cardiomyocyte. Okay, so what will happen, for example, this area is now in the resting state. Okay, but this area is depolarized. But if this area is depolarized, so from the positive, the line move toward the negative. Okay, the line move toward the negative, and you can see what, from negative to positive, from negative to positive, from negative to positive, the line is moving. Actually, this is, if you see from the outside, outside there are negative and here are positive. So this is like, so at this area there is a minus sign, and in this area outside there is a positive sign. So the line move, so the electrical signal move like this. Okay, electrical dipole move like this. Okay, now if it move like this, it mean that if you place electrode like in here in this area, so it give you a signal that a positive, and the positive signal is coming on, positive signal is coming on. So it actually on the electrode they record the positive signal, that positive signal come and then end. First that is coming, increasing and then decreasing and end. So this is actually positive side. If bigger the dipole, if this dipole is bigger, then the bigger the diffraction, so the this will be this will be bigger. Okay, now if there is no dipole, for example, if you see here there is no dipole, all the inside is positive, it is actually polarized, depolarized, it is actually polarized state, but it is actually not resting state. Okay, it is actually polarized state. Polarized state, and it is actually depolarized. Polarization, depolarization, repolarization. It is actually depolarized state, but it give you no signal. Why? Because here is no dipole present, because here is no difference present, but all other depolarized. So that's why it is no dipole and no deflection. Okay, so ECG line will be straight. Okay, now another thing is, if here is the, for example, if this is positive, if this is inside, this is positive and inside here is negative, and the dipole is moving like this, in this direction, from negative to positive. Outside if you see negative, okay, and here is positive, from negative toward positive in this direction. So what will happen? It record the negative deflection, that the deflection move below. Okay, now vector dipole face negative, have negative. Just remember, it give negative deflection. If the bigger the deflection, bigger the dipole. If the deflection is bigger, the dipole will be bigger. Now come here and see. For example, you place the electrode negative and positive here. Okay, and we have already placed there the electrode positive and negative. But if you see here, this line is actually not along the outside the lead we have placed. Okay, so what will happen? So if the dipole is moving like this, what will happen? So you have to make the shadow of this line on this direction, so it will only show the shadow of this direction, only the part of this direction that is like this. Okay, so first of all you have used this mechanism to find their direction in this way, and it give you a deflection that is called, that is simple deflection. Now if you see here, if you place the your electrode in this direction and the dipole is moving in the 90 degree, what will happen? There will be no deflection showing into you. Okay, now from the electrode lead 1 v2 we will extend that little bit. Okay, for example, this is the lead 1 direction. Okay, this is the lead 2 direction, and lead 3 is actually this, so their direction is like this. Okay, so if you see your heart is actually in the direction of the 2. Heart is placed in the thorax like this. So most all of the ECG can be read it of the 2 easily. Okay, so lead 1, lead 2 and lead 3 are actually 60 degree apart from each other. For example, you see here, this is lead 1. Okay, lead 1, and this is lead 2. The angle between them are 60 degree. Now the angle between other are 120 degree, is also 60, so it is about 120, total 120, lead 1, lead 2 and lead 3. Okay, these are the actually all the things I have shown to you: lead 1, lead 2 and lead 3. Okay, this is so simple and I have draw it to you. Okay, now we will move again. Now another thing is about the AVL, AVF, AVL, AVF, AVL, AVF, AVR. So what is the angle between them? If you see, the angle is about 120 degree. Okay, so this is actually the AVL. On the different line we will draw AVL. This is actually AVL. Okay, here it is AVF. Okay, and this is actually the AVR. Okay, AVR. So the angle between them is this is actually 30 degree. Okay, 30 plus this is 120 degree, so the 30 plus 120 is equal to 160. Okay, and 160 plus 120 is equal to 280. Okay, it is like this. So this is all about the angle that is showing to AVL, AVF, AVR. Okay, this is lead 1, lead 2, lead 3. Now come here, and on the chest lead you see there are 6 lead on the chest. 1 2 3 4 5 6. Okay, so if the things are these lead actually monitor the heart through the transverse plane. So lead 1 and lead 2 is actually mostly negative. They show mostly negative deflection. Why? Because actually the heart line move away from this, from this area. Okay, so that's why it is mostly negative, not all negative but mostly negative. And the lead 3, you see, if the lead 3 is actually in the direction of the heart, when the in the direction of the heart, for example in the heart, the electrical activity, it moves through the lead in the direction of the lead 3, so that's why it is called isoelectric line. Okay, now another is the 4, 5, 6. They are mostly positive, deflection. They show mostly positive deflection. Okay, now we isoelectric line, this have isoelectric line I have told you. Now actually r wave progression. What mean r wave progression? For example, if this heart is moved toward the right side, toward the left side, okay, so it will create, for example, the negative, this negative move to like this, to this area. Okay, this and this become less positive. Okay, so from here the r wave is progresses toward the left side, and that is called, that will show you a deflect, that will show you a problem. Okay, we will explain it later. Now first of all, there is a functional. First is mostly I have explained it. Okay, now let come here and see the places where we take the, we places the lead. So the on the one is the on the second intercostal space. Okay, this is the second intercostal space. Is it the third? So we place this area like v1, v2, v1, v2, v3, v4, v5, and v6 in the auxiliary line. Okay, mid auxiliary line we take the v6. Now if you see v1, v2 actually monitor the septal lead from the right side. Okay, from the right side, and v2, v3 actually see from the septal side. Okay, and v3, v4, v5, v6 actually from the left side. Okay, and both of them, v5, v6 and v3, v4, they are actually anterior in the function. If you see the function, they are actually anterior. Function is anterior. Okay, and v1, v2 is actually, they show the function of the septum. Okay, right, it is actually direction right. v3, v4 is actually septal, and v5, v6 actually left. But left, v5, v3, v4, v5, v6, they are actually anterior lift on the as a functional wise. Okay, now we will come here and will understand all the leads. Okay, that what lead is present to which side. Now first of all, right coronary artery. There are two coronary artery. One is the right coronary artery, and the other is left coronary artery, anterior side, left anterior descending artery, LAD. Okay, so lead 2, and lead 3, and AVF. This is on the inferior side. And actually it is showing this side. Okay, and they are controlled by the right coronary artery. So if lead 2, lead 3 and AVF, if there are any abnormality in this lead, so there will be a right, this will be a defect in the right coronary artery. So you have to remember that the lead 2, lead 3 and AVF, if there is abnormality present in this lead, what will happen? The right coronary artery have a defect. Okay, now another thing is about this septum. Okay, septa. So septal lead are actually v1 and v2. You have to remember, on the septal lead are v1 and v2. If there is any abnormality, there are near the interventricular septum. Now another thing is the lateral lead. Lateral lead are actually, one is the lead 1. Lead 1 is also lateral side. Okay, and another is the all the lead, AVL. Another is the AVL. Also AVL. Okay, 1, 2, and v3 to v6, v3 to v5, V3 to V6 are actually lateral lead. V3 to V6 are actually lateral lead. Okay, they show the lateral side. So anterior lead are, this is anterior lead. Anterior lead are V3, V4. Okay, anterior side of the heart. And V1, lead 1, AVL, and V5, V6, they are lateral side. So there are two. One is the anterior lead. Anterior lead are V3, V4. And lateral lead are lead 1, AVL, and V5 and V6. Okay, not V3, V5. Lateral lead are lead 1, AVL, V5, V6. Okay, but the anterior lead are V3 and V4. Anterior lead are V3 and V4. Now another thing you have to remember that if in the V1, V2, V3, V4, if there are any abnormality, what artery will be defect? The LAD, left anterior descending artery, will be affected. But if there are effect in the lead 1, AVL, or V5 to V6, there will be lateral circumflex artery. Okay, lateral circumflex artery will have a defect. Okay, now I have explained these things. Okay, now you have to just revise it. Okay, it's so easy. Now after that we will explain the ECG, cardiac hypertrophy and enlargement. But let's revise it again. This lead. Okay, how you can revise it? This is your heart. Okay, this is the lateral side, this is the septal side, and this is the anterior side. So septal are actually V1, V2, anterior are V3, V4. Okay, these are the anterior lead. Now these are the anterior lead. If there are any defect present here, this will be LAD will be affected. Okay, and now this side, if you see this area, this is toward the inferior side, and if you see the inferior side, there are lead 2, lead 2, lead 3, and AVL. These three lead, if there are any defect in these three lead, so this is toward the inferior side, and this will be right coronary artery will be defect, will have a defect in the right coronary artery. Now it is lateral side. To the lateral side, you see that which lead, for example, to the arm side, lead 1. Okay, and AV, this is actually AVF. Okay, AVF, not AVL. Lig, not. I understand that L means lig, but AVF, F mean foot. Okay, so these are right coronary. If there are any effect, there will be right coronary artery. Now show here. This is lead 1. This is AVL, and another is the V5, V6. If there are any defect in these four, there will be lateral circumflex artery will have any defect. Okay, so you have to remember this sketch very easily. Okay,